Checking mic. Exhaust gas recirculation. It's probably the same. No AirPods. Now with AirPods. We are going to talk about exhaust gas recirculation systems. This is another common emission control device that we find on a lot of vehicles. Most modern vehicles, we've seen this system kind of fade away. We'll talk about what the shift is there. But let's start with the basic idea of it. So it's typically referred to as EGR. It is there to recirculate exhaust gas for emissions purposes. We're trying to lower the amount of NOx or nitrogen oxides that get formed during combustion. Why do we want to do that? Well, NOx is one of the biggest contributors for smog. So we see it as a big issue with air pollution, and so we want to do what we can to reduce that within vehicles. And some of the science behind that, NOx is formed, as we talked previously, in high temperature combustion. So anything that exceeds 2,500 degrees Fahrenheit. So we want to lower that temperature. So what can we do? Well, this is where EGR comes into play. So EGR tries to keep that temperature down by putting exhaust gas in small quantities back into the combustion chamber. So typically about 6 to 10% of the air in the combustion chamber being exhaust gas. And because exhaust gas is inert, meaning it doesn't have any properties for combustion, that's going to lessen the amount of oxygen in the combustion chamber, which is going to lower the temperature. Just like when you build a fire, you need a surplus of oxygen to really get that fire to ignite and go and burn. By reducing oxygen, we're going to somewhat starve that flame, and so that flame will be smaller. The operation of it uses a valve. This valve here in this diagram, you can see at the bottom, we connect to the exhaust gas, so we have to be connected to a manifold, and then we need a connection to the intake manifold. And this valve has to be able to withstand heat and all of the soot and carbon that comes through that system as well. So this particular one is a vacuum diaphragm base. It uses intake manifold vacuum at the top to modulate flow through that valve seat. The spring provides stationary pressure to keep it closed when it's in a static state, and then again vacuum from the engine can overcome that spring pressure to create flow and an opening in a dynamic controlled state. We see these valves built in a variety of ways. One of them would be directly connected to an electronic solenoid. Those valves are pretty common, generally only 2 wires for at least the solenoid operation. Sometimes we see more wires whenever we put position sensors and other feedback information into those. But at their core, it's a solenoid, so that valve is either open or closed. So we'll talk about the strategy there. Could be a stepper motor, or as we just looked at, that vacuum diaphragm, where we're utilizing a solenoid to control the vacuum source to the valve itself. Similar picture here to the one we just looked at, a little bit less information. We'll skip by that. So overall in this system, I've got my valve as kind of the core, looking at flow and no flow. I often have some kind of pressure or temperature sensor to help me understand whether or not flow occurred. So that's the feedback loop of this process. And I've got to have the PCM involved as well. And so there's a variety of ways that we're going to control these valves. If I've got the diaphragm type with a solenoid controlling vacuum, that solenoid can only be on and off. And so I've got to pulse it and establish a duty cycle in order to get percentages of flow, less than 100% or more than 0%. Same thing occurs with that solenoid that directly controls the valve. The stepper motor has a more analog and variable approach to it, where I can enter specific count or percentage of travel in order to achieve those small flows that are 3%, 4%, to try to build into full flow at different times. And so in the service side of this, when does it come up? Well, let's talk about where EGR operation occurs. EGR operation typically occurs at cruising, generally with higher speeds and higher torque demands. So when we're at a low RPM and we ask more of the engine, there's typically under light throttle type applications. That's typically where we're going to see lean conditions. And so the EGR valve interacts in that scenario to try to lower NOx. So here's a common customer concern that could be EGR related, right? So we could have poor idle, a hesitation, or some kind of bucking during acceleration. And so why do those things occur and why could they be linked to EGR? A couple things. One, if we look at this picture, this is a pretty common Ford style EGR system where the valve is mechanical with the diaphragm. That diaphragm is controlled by the electronic vacuum regulator, EVR. That's right up here. That EVR is regulating engine vacuum to the valve, ultimately controlling the flow. Down here, the unique piece that Ford operates with is this DPFE sensor. And so that's the differential pressure sensor. It's looking at two inputs. It's got essentially two map sensors inside. It has reference to a point of the EGR tube before and after an orifice. So if there's flow going through this tube, traveling upwards to the intake manifold, when flow exists, there'll be a pressure differential between the area before and after that orifice. This sensor's job is to see that and communicate that to the PCM so that we know that, hey, we asked for the valve to open. Did it occur? And so that's the primary goal of that system. And so if you look at that track and think about this, if that valve was to be stuck open, I would have excessive inert air traveling to the intake that would have a dramatic impact on my idle quality and my drivability. The same could occur if that valve was to remain stuck closed or the passageway or EGR tube became clogged. Now, when I go ask for EGR valve operation, the PCM may still make fuel changes in anticipation of a leaner condition because of that inert gas, and then that would reflect in the drivability issue as well, right? So in both situations, we essentially had air going through the system that we didn't expect, and so we could have two different outcomes with that, but both are undesirable. And so while we talk about the service side of things, what could go wrong with this? Obviously, the valve itself has to actuate. So these valves do see some problems. They see a lot of heat. They see some moisture through condensation. Carbon buildup is also a pretty prevalent issue in these systems, right? So those are some of the prominent things. One of those examples is that Honda, with some of their V6s for a period of time, had an issue with carbon buildup in the passageway in their intake manifold. And so they had this service bulletin that directed you to buy one of these kits. And so you can see this little stainless tube, a new valve, and a couple of gaskets to go through this process. And so I'm going to ask that you go through this bulletin as an assignment because it's a pretty interesting one. It has you details well how to clean out that port, and then their remedy was to put this stainless insert there to try to help prevent clogging in the future. And so that's really where a lot of our time gets spent as a tech on these older systems, is often with carbon buildup. Lower quality fuels tend to influence these systems being caked up worse as well. And so here's some examples. System on another Honda, 4-cylinder at this point, where you can see the different setups of EGR passageways. This is an example of a passage within an aluminum cylinder head that is almost 100% clogged. Here's an example at a valve where it's about 50% or better clogged. And so all these situations can create issue with operation. And so being able to determine through some scan tool testing or other mechanical testing, whether or not we have a flow problem, is a good skill set to have so that we're not needlessly taking things apart just to inspect them. That's something that we want to avoid. So really we want to start with that question: is there flow? So do we think that the valve can operate? And then do we think that the passageways are clear? And so there's some different ways that we can do those things. I'm going to put up another separate video going through some basic EGR valve testing on a Ford Ranger in the shop. So we'll be able to look at that. But some of the other things that I don't talk about there: coil resistance, motor operation, those are things that are really well done with the scan tool. Coil resistance specs are something we might find from a manufacturer, but static resistance testing is generally not the best practice that we can have. So in that video with the Ranger, I'll go through applying vacuum to a valve in order to show that I could control that vacuum and then see what happens. I could also do that with a scan tool. And when I do that, I should see the engine shudder or even stall. And so why? I'm putting inert gas in when the PCM doesn't expect it, at idle where it can't really sustain that, and doing it in such increased volume that the idle quality will be really, really poor or might even stall the engine. And so if that happens, that's a good sign. That shows me that the valve can work, it can flow, and there is an impact that occurs. And so this system is a great example of just the complexity that exists here. Several different pieces I've got to keep in mind whenever I go to work on this system. The upside to this is that on most modern cars, we've gotten away from EGR. Their technology in other areas have really allowed us to defeat some of these smaller systems. And so EGR is one of them that's largely gone away because of variable valve timing becoming so prevalent. So variable valve timing, right, is the electronic control of camshaft timing, often done with pressurized oil through a camshaft gear phaser. So there's somewhat of there are two chambers within, or a large chamber within the camshaft phaser that allows me to advance or retard the cam gear at different points of operation. And so for us with EGR, we can phase the exhaust camshaft, and typically we're going to close the exhaust valve early. And so what that does, you can imagine the piston traveling from bottom dead center to top dead center. In the exhaust stroke, it should be doing that and pushing all the exhaust gases out because the exhaust valve is open. If we close the exhaust valve early, there's going to be some exhaust gas trapped and left in the cylinder for that next cycle, and that's ultimately going to provide the same operation as this EGR valve does for us. And so relatively easy programming for us to add, make it conditional, make it go through similar steps to the previous systems, but now we don't have to worry about this extra exhaust tube, valve, and other supporting components. That's what I've got for EGR. Thanks for listening. Make sure you go check into Cobra, look for the assignments that we've got, and have a good day.